We'll look at two equations, both given in standard form. Here's our first one. F of x is equal to negative x squared minus 2x plus 3. We'll find all the key points and graph it. The key points, of course, are the vertex, the y-intercept, and the x-intercepts. Before we even get started, before we even find the vertex, what can you tell about this function? Well, certainly it is a parabola, and it is written in standard form. We know it's a parabola because the highest power that x is raised to is a 2. It's in standard form. It is in the form f of x is equal to ax squared plus bx plus c. I also know that this parabola will open downwards, which means that its vertex will be a maximum point. It opens downwards because the value of a, the coefficient of x squared, is a negative value. All right, let's get started with finding the vertex. We find the x component of the vertex by evaluating negative b over 2a. You'll see that in our cheat sheet over here. The x component of the vertex can be found by evaluating negative b over 2a. To be very clear here, the value of a is negative 1, the value of b is negative 2, and the value of c is 3. This just helps us to fill in the blanks easily. So we have negative 1 times negative 2, all divided by 2 times a, or 2 times negative 1. So we have positive 2 in the numerator, negative 2 in the denominator, or negative 1. Now to find the y component of the vertex, we're told to evaluate the function at negative b over 2a to find f at negative b over 2a. Well, we know the value of negative b over 2a. We just found it. So we're going to evaluate the function at negative b over 2a, or negative 1. That gives us negative 1 squared minus 2 times negative 1 plus 3. Or negative 1 times negative 1, or negative 1 squared is positive 1. Negative 2 times negative 1 is positive 2 plus 3. And negative 1 plus 2 plus 3 is positive 4. So the vertex has the xy coordinate, negative 1, positive 4. Let's find the y-intercept. The y-intercept occurs when we set x equal to 0, or we find it when we set x equal to 0. As a result, the y-intercept is equal to c. So the y-intercept here is just equal to c, or positive 3. As a coordinate pair, this is the point 0, 3. Next, we'll find the x-intercepts. So the x-intercepts we'll find using the quadratic formula. Of course, we've set y equal to 0 to find these, so we're solving for x given that 0 is equal to negative x squared minus 2x plus 3. Of course, we already know the values for a, b, and c, so we simply fill these in. So we have x is equal to negative b, or negative times negative 2, plus or minus the square root of b squared, so that's negative 2 squared, minus 4 times a, which is negative 1, times c, which has a value of 3 in this case, all divided by 2 times a, which in our case is negative 1. So we find that x is equal to positive 2 plus or minus the square root of 4 plus 12, all divided by negative 2, or x is equal to 2 plus or minus the square root of 16, 4 plus 12 is 16, and the square root of 16 is 4, all divided by negative 2. So x is equal to either 2 plus 4 divided by negative 2, or x is equal to 2 minus 4 divided by negative 2. In the first instance, 2 plus 4 is 6. 6 divided by negative 2 is negative 3. And in the second instance, 2 minus 4 is negative 2. Negative 2 divided by negative 2 is positive 1. So the x-intercepts for this function are the points negative 3, 0, and 1, 0. Now that we have the x-intercept, the y-intercept, and the vertex, let's summarize those and draw the graph. So we have a vertex of negative 1, 4, Our y-intercept is the point 0, 3, and we found that we have two x-intercepts, both real values. The first is -3, 0, and the second, 1, 0. We'll find these points on the coordinate plane. First, the vertex, the point -1, +4. Then the y-intercept, the point 0, 3. The x-intercepts, the point -3, 0, and 1, 0. And really, that's enough for us to draw our parabola. We can find an additional point on this graph by using the axis of symmetry and recognizing that we'll find what happens to be the y-intercept on the opposite side as well. Be sure to connect those points using a smooth line to draw a parabola. Numbers worked out nicely for that previous example. This one isn't quite so nice. So let's have a look at what happens when our values are a little bit more cumbersome. Let's start by finding the vertex. For this parabola, again, I notice that we are in standard form. It certainly is a parabola because the highest power that x is raised to is a 2, and I notice that it opens upwards. I notice that it opens upwards because the value for a, the coefficient of x squared, is positive. I may also notice that because a is a value larger than 1, that the arms of the parabola will be slightly narrower than usual. As always, let's start by finding the vertex. We find the x component of the vertex by evaluating -b over 2a. Let's first write down the values for a, b, and c. A has a value of +3, b has a value of -7, and c has a value of 6. So we have negative, it's -7. I'll divide it by 2 times 3, or +7 over 6. So the x component of the vertex is 7 over 6. To find the y component of the vertex, we substitute the x component into the equation. So we find f at 7 over 6. So we have 3 times 7 over 6, all squared, minus 7 times 7 over 6, plus 6. Let's simplify that. That gives us 3 times 7 over 6, all squared. 7 squared is 49, 6 squared is 36, minus 7 times 7 over 6, multiplying the numerators gives us 49, and that's still divided by 6, plus 6. 3 times 49 over 36 can be simplified before we do the multiplication. If we realize that 3 and 36 are both divisible by 3, that leaves us with 12 in the denominator. So we have 49 over 12 minus 49 over 6 plus 6. You can absolutely do this arithmetic yourself by rewriting all three fractions so that they have the same denominator, ideally the lowest common denominator, or you can plug these into your calculator using the fraction key. Either way, you'll find that this is equal to 23 over 12. All right, so the vertex in this case was the point 7 over 6 and 23 over 12. Because we'll be graphing this isn't necessarily the best way to write this. Perhaps you write this rather than using improper fractions, using mixed fractions. 7 over 6 can be written as 1 and 1/6, and 23 over 12 can be written as 1 and 11/12. That already gives me a better idea of where I should place those points on the graph. Again, it's probably not as easy as decimals. We could probably go another step and rewrite this as 1.17, 7 over 6 is equal to 1.17, and 23 over 12 is equal to 1.92. So a little greater than 1 and a little less than 2. The y-intercept, well, that's just equal to c, so the y-intercept is equal to 6, and let's remember that that's the point 0, +6 on the coordinate plane. So I've tidied this up so that we can find the x-intercepts. Of course, we find the x-intercepts by setting y equal to 0. So we're solving for x given that 0 is equal to 3x squared minus 7x plus 6. I've already written down the values of a, b, and c up here, so we can go ahead and plug those in. So x is equal to -7 plus or minus the square root of -7 squared minus 4 times a, or 4 times 3, times c, which has a value of 6, and all of that is divided by 2 times a, or 2 times 3. So x is equal to 7 plus or minus the square root of 49 minus 72, all divided by 6. So x is equal to 7 plus or minus the square root of -23 divided by 6. Now you'll find that if you try to punch in the square root of -23 in your calculator, that it'll give you an error. We can't take the square root of a negative number. What this means is that although this is a number, it's a complex number. It has an imaginary component. It means that there are no real intercepts or no real roots. That means that this parabola doesn't cross the x-axis. Let's have a look at what that looks like in graphical form. To summarize, we found that the vertex had a value of approximately 1.17, 1.92. The y-intercept is the point 0.06, and the x-intercepts, well, those were not real numbers. So while we can certainly quote the imaginary numbers, for the purposes of graphing, they're not valuable to us. Where is the vertex? Well, we'll find that at the point 1.17 and 1.92. It's right here on this graph. And the only other point that we know is the y-intercept, 0.6. You can use symmetry, so find the axis of symmetry. It's the vertical line that runs through the vertex, which allows us to mirror the point 0.6 on the other side of the parabola. So this function starts above the x-axis, and because it opens upwards, and it opens upwards quite quickly, in fact, but because it opens upwards, it never crosses the x-axis. So there are no real roots for this function.